In this section, we're going to discuss exponential functions. Exponential functions are functions that look like f of x is equal to b raised to the x power. And the biggest thing that makes them different from other kinds of functions is the fact that the exponent is the variable part of the function, where the base, the thing that is being raised to the power, is just going to be a constant. Specifically, the constant has to be greater than 0 and not equal to 1. So when we see situations like this with a variable exponent but a constant number for the base, we produce what's called an exponential function. And so you see that in some functions like this one here that says f of x is equal to the x power. So again, the base is just a constant number 2, where the variable is the exponent x. Same thing if we had a function like 10 to the x power. That would be an exponential function. Even things like 3 raised to the x plus 1 power would be an exponential function. And even fractions for bases, like 1/2 raised to the x minus 1 power, that would be an exponential function as well. Things that don't look like exponential functions are things like x to the second power, and that's because we have a variable in the base rather than the exponent. The exponent's the constant number of 2. A base of 1, like 1 to the x power, would not be an exponential function, primarily because 1 to any power is just 1. So we don't consider that one an exponential function. Same with negative numbers, negative 1 to the x power. While the exponent is the variable, the base is a negative number, and those situations don't produce exponential functions. Even weird situations like x raised to the x power would not be an exponential function because the variable is in the base as well as the exponent. So in those situations, we would not have an exponential function. Only in the cases like up above here where we had something like 2 to the x or 10 to the x, stuff like that, will be situations where we have exponential functions. So there are certain situations where we need to calculate things using exponential functions and so forth, and the numbers are kind of weird. Like for instance, 2 raised to the 3.4 power. It's kind of a weird thing to do, but the calculator can handle it just fine. The way we do this in the calculator is I'll press the button for 2, that's the base, and then to get the exponent, we press this button right here, that's above the division, below clear, and that button will let us enter in any exponent we want to. So once we press that press that button after hitting 2, it puts us up in the exponent's position like this. And so we can press 2 and then raise that to the 3.4 power and hit enter. And so let's round that to the nearest tenth. That would be approximately 10.6 when rounded to the nearest tenth. So I'll just put that down here, approximately 10.6. We can even do things with negative exponents in the calculator as well. If we just press 6 raised to the negative 1.2, hit enter, and we'll get approximately 0.12 rounded to the nearest hundredth. And now there's this special base called e. It's referred to as the natural base. And we can calculate things with base e by using the calculator. I go over here, and the button for e is right above where it says ln, is where you see e to the x there. So we use the ln button in order to get there. But what we have to do is we have to press second first. So we have to press second, and then we have to press ln. And then that puts e to the power onto the calculator. to which we can just put in e, then raise that to the 2.3 power, hit enter, and that gives us approximately, let's say, 9.97 as our result, rounded to the nearest hundredths. So we're always going to have to round off to some degree here when we do these calculations. Hundredths, thousandths, tenths, it'll vary depending upon what we're trying to do. So anyway, that's how we calculate, using the calculator, exponential type things like this, kind of different powers, different exponents, and this base e specifically, and how we're going to be using that for doing a lot of different calculations here pretty soon.